Hello ladies, so today we're going to take a look at Riemann sums and trapezoidal rule. And one thing you're going to notice is the very similar idea as to all the different areas we've been taking, except this time we won't be using shapes that have an easy formula for area. So what we're going to actually end up doing is we're going to do an estimation. So keyword, these are estimations, they're not exact like our previous examples. And anytime you see Riemann, I want you to think of rectangles. And anytime you see trapezoidal, we're going to be working with trapezoids. So rectang, I think I'm missing a G, rectangles. Okay? So the first thing is our right Riemann sum, or our right rectangle sum. So according to this, it says the graph of the function f is shown below. Approximate the integral from negative to 4 using a right Riemann sum with 3 subintervals of equal length. Sketch the graph of the right Riemann sum. So what we're actually going to do is we are going to draw rectangles under this curve. And the first key thing is we need to find out how many rectangles we need. So according to this, it's telling me I need 3 subintervals of equal length, which means I need 3 rectangles. And I have to go from -2 to 6. So if I want to check how long that is, I notice from -2 to 6, I have 1, 2, 3, 4, 5, 6 spots. So in order to get 3 intervals of the same length, I know that I need these intervals to be a width of 2. So there's one rectangle right there, another rectangle right here, and then I have a final rectangle right here. Aren't those 3 subintervals of equal length, right? There's 3 intervals, they're each 2 apiece, and it goes from -2 to 4. So what we're going to do is we are then going to take a look at where I need to draw these. So what I have is my number line right here. And I see I have 3 different intervals, and I have -2, 0, 2, and 4 as the x values. Since this is a right Riemann sum, I'm going to draw a triangle every time I'm on the right hand side. So from -2 to 0, this is my right hand side, so I draw a rectangle here. This is also a right hand side, so I draw a rectangle here. And here is a right hand side, so I draw a rectangle here. So then what I'm going to do is I'm going to color in those same rectangles on this spot. So according to this, my first rectangle happens when I hit 0. So I'm going to draw a line until I hit the graph, and then I'm going to connect it to this side to create that rectangle. So this rectangle was created by using the right side to draw the graph. I do the same thing for the second rectangle, and I notice that happens at number 2. So I go to number 2. So I go to number 2, and I draw my line until I hit the graph. And here I hit the curve when I'm at 5. I go towards the left-hand side, and then I color in my rectangle. So once again, I drew a rectangle using the right-hand side of my formula. And so the last step is to do one at 4. And if I take a look at 4, I notice 4 already hits. So this would just be at 0. Since I'm looking at areas, we know the area of a rectangle, and we know that's the length times its width. So if I take a look at that, I have 1, 2, 3 rectangles that I can take the area of and add. So what we're going to do is we're going to take the width, oops, let me use a clearer pen. We're going to take the width times the height of this rectangle plus the width and the height of this rectangle plus the width and the height of this rectangle. And I notice the width of every single rectangle is 2. So this is 2 times this height is f of 0. So this is where we had the height. The next one is 2 times f of 2, since that's this height right here. So let me draw that in. This height. So f of 2 plus the last one. Let me scoot all of this over. Move that 2, move this. We see we get 2 times, the last one is f of 4. So I use the graph to solve these, and I get 2 times f of 0 is 1, plus 2 times f of 2 is 5, plus 2 times f of 4 is 0. If I add all of these up, I get 2 plus 10 plus 0 gives me 12. So this is an approximation that if I take a right Riemann sum, my area is going to be approximately 12. So let me keep note that this is an approximation. Okay. Well, if I can do a right Riemann sum, I then have to do a left Riemann sum. So if you take a look at the next problem, it says, here's the graph. If you notice the same exact graph, I want 3 subintervals of equal length from -2 to 4. So once again, I go from -2 to 4. I want 3 equal rectangles, so that also gives me from -2, 0, 2, and 4. But now I want the left-hand side. So if I go from the left, here's a left-hand side, here's the next left-hand side, and here's the next left-hand side. So I do the same thing. When I go to the left-hand side, my first left hand is -2. I draw a line from -2, and then I continue until I hit 0. So now my first rectangle is this right here. So let me color this in like a little first grader. So the next piece is from 0 to 2. The left-hand side of 0 to 2 is 0. So when I take a look at 0, this is where 0 hits, and I go all the way up until I hit 2. And there is my next rectangle. And the final rectangle is when I hit +2. So on +2, I notice that hits up at the top, and then I need to color all of this in. Once again, I have 3 rectangles, and I know the area of every rectangle is length times width. Each of these have a width of 2. But now I need to plug in my left-hand side. So that's f of -2 plus, over here I have f of 0, 2 times f of 0, plus, again, let me move this over, plus 2, in this case it's 2 times f of 2. I plug everything in and I get 2 times, this right here is a +5, plus 2 times, this is a 1, plus 2 times up here is a 5, which gives me 10 plus 2 plus 10, which gives me an area of 22. So if I'm looking at a right-hand side Riemann sum, I need to make sure I start drawing a triangle on the right-hand side of the limits. And if I'm looking at a left-hand sum, I need to start drawing the triangles on the left-hand side of the Riemann sum. So there is another kind of sum that we're going to take a look at for today, and that is a midpoint Riemann sum. So if you take a look at the previous example, most of my areas were under approximation. I have a lot of pieces of the graph that are not shaded in. In this case, you notice I have too many pieces of the graph that are shaded in. So if I pick a midpoint Riemann sum, I should try to get a better estimation that's in between my 12 and my 22 from our previous answers. So for a midpoint Riemann sum, same thing, same graph. I go from -2 to 4, and I know I have 3 subintervals, so my subintervals are actually the same exact thing. I have a subinterval from -2, 0, 2, and 4. Now what you notice is, since this is a midpoint Riemann sum, I need the middle numbers between these ranges. So between -2 and 0 is -1, here is 1, and here is 3. So first thing is mark off where my rectangles are, and that would be -2 to 0, 0 to 2, and 2 to 4. But now I'm going to draw a line up until the midpoint. So the first midpoint is at -1. I'm going to draw, over here, my -1 shows me that I draw a line up to here, and that is how tall I want my rectangle to be. So then I color this in. If you notice, I color this in yellow right here. And my midpoint was -1, so that's how tall my rectangle is going to be. The next one is when my midpoint is at 1. So here's 1. If I hit the graph, I see that's where my rectangle is going to stop. And then I color this part in right here. And then finally, I see that the midpoint is 3, so I draw a line at 3. And then I create a rectangle right here. So if you notice, I have less of the area outside of the curve and more of the area inside of the curve. It's still an approximation, but still works. And then if we calculate this, my width is still 2, right? Isn't this 2 right here? This is also 2 right here, and this is also 2 right here. So I get 2, but now it's f of the midpoint. My first midpoint was -1 plus 2 f of the next midpoint was +1 plus 2 times f, the next midpoint was 3. And I plug in and I get 2 times -1's value was 2. 2 times +1's value was 3. Plus 2 times +3's value was 4. So I just do the math. Get 4 plus 6 plus 8, which gives us an area of 18. And if you notice, 18 is in between our 12 and our 22. So I'm getting a better approximation. Okay? So what we'll do is tomorrow we'll take a look at the trapezoidal rule and see if this is an even better approximation of the left, the right, and the midpoint Riemann sums. Thank you.